So the another method of improving the efficiency of a turbine is by intercooling. See, major power consumption is by the compressor, correct? So whatever the work which is developed by the turbine, the major part of it is consumed by the compressor. So we can reduce the power consumed by the compressor by splitting up into two compressors. That means you are compressing the gas from 1 to 2 in two stages by using a low pressure compressor as well as the high pressure compressor. So between these two, you are adding up a intercooler that functions from 2 to 3. So what happens exactly is you are compressing the whole gas in two stages, that is from 1 to 2 in one stage using a low pressure compressor, and from 3 to 4 in the another stage using a high pressure compressor. So between these two stages, what you are doing is you are decreasing the temperature rise from 2 to 3. You are decreasing the temperature from 2 to 3 by using an intercooler. This particular thing will add up to more number of efficiency for a gas turbine. So this is the TS diagram which represents the same thing. You know that 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 6 and 6 to 1 all are ideal in nature. If efficiency of the low pressure compressor is considered, then it is 1 to 2 dash, not 2. If efficiency of the high pressure compressor is considered, then it is not 4, it will meet up to 4 dash. If efficiency of the turbine is considered, then it will meet up to 6 dash, not 6, which is ideal in nature. So the important point to be remembered is for the perfect intercooling, that means what is meant by perfect intercooling? Whatever the temperature rise that has been caused by the low pressure compressor, that is from 1 to 2, that whole temperature has to be reduced back to 1. Then you can say the intercooling that is functioning from 2 to 3 is perfect. That means if the temperature T1 is equal to the temperature T3, that means it has brought down to the initial temperature completely, then only it is known as a perfect intercooling. So for the perfect intercooling, T1 would be equal to T3. Now, how do you calculate the efficiency of this? Efficiency is given by the work net divided by heat supplied. Remember, work dones are always calculated initial minus final, and the heats are always calculated final minus initial. Okay, so the work done, you can watch the equation in the next page. Meanwhile, you can take the notes as it is. Okay. So the work net divided by heat supplied gives the efficiency of the turbine. So the work net is nothing but the turbine work plus compressor work. So turbine work is T5 minus T6, initial minus final, plus there are two compressors. Remember, there are two compressors, one is LP and other is HP. So LP is given minus T2 and HP is T3 minus T4, which are all initial minus final. The whole thing in the numerator is work expression, so it is initial minus final, whereas QS is heat, so here it will be final minus initial. So you can even take the note for the perfect intercooling, T3 would be equal to T1.